Hey everyone, welcome to reInvent 2024. Really happy to see everyone here in the audience, and really glad to be one of the first folks to speak with you. We're here to share with you how AWS is looking at accelerating app maintenance and upgrades with GenAI. Um, just curious, I know we're sort of starting out, but a quick show of hands, how many of you guys are going through sort of any of these app maintenance and upgrades or modernization projects with Java? We got quite a few hands. Awesome. Great. Well, hopefully we can share some of the knowledge here and go from there. So my name is Adnan Dilwani. I am the principal specialist with the Next Gen Developer Experience team here at AWS. With me, I've got my colleague, Elio DiMaggio, who is the product owner for Amazon Q. We've also got Amber Bird, who is the AVP engineering at Canada Life. She's here to share about her real-world experience of how they have looked at this use case as well. Let's take a quick look at the agenda today. So we'll start by talking about, I know a lot of folks have been going through this legacy application upgrades and modernization. Let's talk first about what we mean by when we talk about applications, what all the different layers are. Let's set up that baseline and common understanding for our discussion today. Then we can kind of talk about what GenAI and how AWS is trying to leverage GenAI for this to begin with. We'll talk about how folks work today. Would love to find out from you guys how you folks have been potentially utilizing some of the tools or how you've been sort of doing this as well. Then let's talk about how AWS is thinking about leveraging generative AI to accelerate some of this as well. We'll then walk into and hear from Amber around how Canada Life has been looking at this use case and how their teams have been trying to accelerate their process as well. Last but not least, hear from Elio around it's a reInvent, so what's new, what's happening, and share some of the new things that are up and coming as well. Cool. So let's get started. Upgrading legacy applications, right? Crucial consideration for businesses aiming to maintain, basically be competitive and efficient as they go through, right? Increasing performance and efficiency, resolving security risks, staying up to date with vendor support, adding scalability. These are just some of the terms you hear, right? On the reasons why folks are looking at it as well. Curious, just anybody else has any ones that I've missed here? Curious what you guys are thinking of. Anyone? Too early in the morning? Okay. But before we get deeper into the how, right, let's set up the common understanding of the anatomy of an application, basically, and which upgrades are we speaking about today. So let's quickly take a look, right? Well, this can be done in many ways. Let's keep it simple. I've divided an application into 4 layers. We'll start with the infrastructure layer, right? This consists of your computing resources, your networking infrastructures, potentially peripherals as well. We layer on the operating system, right? Windows, Linux, you name it. Then we move on to the choice of programming languages, frameworks, packages. This sort of forms that base layer, right, of that application layer that's up top. And that's basically where your application code resides, your data resides, right? Data schemas as well. From an end user's perspective, or from your end user's perspective, that's kind of where the magic happens as we go through. However, from an application perspective, right, all of these layers require maintenance and upgrades at some point in time. But they are sort of all handled differently a little bit as well. And I'm sure depending on where you are within your maintenance maturity models or within your organizations, how maintenance is being looked at, you are handling them differently a little bit as well. We start with the infrastructure layer, right? Upgrades typically are what? Every 3, maybe 3 to 5 years potentially. This is again your servers, your hardwares, right? Your network configurations as well. You may increase or decrease this depending on sort of the load you're looking at as well. So that's important. From an operating system perspective, you get regular security patches, regular sort of minor version updates as well as we go through that. But that's sort of done more of an automated fashion. So, the system is a little bit mature in terms of making that happen a lot more automated. Of course, there are major updates. It happens every 1 to 2 years now, I think, at this point in time. And those can be a little bit challenging, but usually the regular updates are not that hard to apply. Now we focus on the frameworks and upgrades and what your programming languages are, right? So, hey, if you're working in Java applications, right, you've got your Spring Boot, Hibernate, Struts, pick your framework sort of a deal. Performance or updates for security risks and stuff are applied. And I've gotten a mixed bag of sort of where folks are with that, right? The security ones are applied often. Things that are sort of at performance risks or performance additions that you can see your feature requests. Those can be delayed sometimes depending on how your business considerations are. So I kind of hear a mixed bag of when and how those updates are applied. Major updates, of course, come every year or so as well on some of those things as well, and then can be challenging as well. One of the biggest things with applying updates here, especially if you wait a while, is they can contain breaking changes that actually kind of, deprecated APIs are one of them, and so on, to kind of break that top layer up top, right, and force you to sort of make changes up there as well. So, but going on to your application layer, right, bug fixes, security updates, again, applied more frequently. However, refactoring, performance improvements sometimes can get deprioritized as well, right, depending basically on what your business requirements are. You kind of work more on your application towards adding those features or whatever is driving your business and innovation first. Some of the other stuff can sometimes take a second seat. Today, when we're talking about GenAI and leveraging it, we're talking about some of those hard to find or hard to make maintenance updates that we do across those two layers as we go through. All right. Now, let's assume we are still making some of these changes as we go. And if we actually start delaying some of those changes as we go through, they then tend to become more of a modernization project, right? They go from maintenance to modernization. So this can really become a concern. Of course, it can be very tedious and time consuming. And then it comes back to the whole undifferentiated heavy lifting that always developers kind of shy away from a lot as well. How are people doing this today? Short answer, mix of automation and manual work. Anybody got sort of percentages in terms of what folks out there are sort of doing? Just curious. More automation? 80-20? Automation, I like that. For automation for 80? Anyone else? Any percentage? 20-80, he owns the opposite. So it does kind of depend, right, on sort of where you are on your maintenance journey or your maturity model on that conversation, right? But yes, the point is there's tooling out there that you can potentially apply scripts to update, let's say, major frameworks, right? So you've got recipes that will update Spring Framework for you and get you to a certain spot. You do have to learn those tools. You have to maintain that. Some of our zealous developers are potentially putting our own custom scripts to kind of take that a little bit further. How many of you guys are developing custom scripts to do this? Anybody? Oh, I got a few. Okay, awesome. Right, and then deprecated code, that's where a lot of the manual changes come, and first-party packages get a little bit more, adding more unit test documentation, right? A lot of that could come manual. So there is sort of a balance in terms of what it can do. So let's look at a typical Java workflow, right? How do developers do this today, right? Let's say you're going from Java 8 to Java 17 or 21, 6.17 for now, for a minute. You've got a Java 8 app, Java 6 maybe. Actually, I'm really curious. How many folks here are older than Java 8 apps or applications? Got a few. How many Java 8 folks? Okay, makes me sound a little brief. Awesome. 17? Oh, like it. Okay, awesome. So, you've got a Java 8 app, right? You take that application, you utilize some sort of scripts, automated, go ahead and apply some of those changes. You've upgraded a bunch of these frameworks and dependencies. You get to a certain spot, right? You may make some manual changes that you already know of as well, and you've made them. What's next? You go ahead, compile, test, possibly, more likely than not, run into errors and issues, and then you basically go and do that rinse and repeat cycle, right, of fixing some of these, testing them out, seeing where it is, and the idea being, hey, let me get to a spot where I am hopefully getting to a point where it's Java 17 compatible, everything is looking good, goes to UAT and production. But what if, you know, we could actually go ahead and automate some of that portion as well? So what if we could leverage GenAI to analyze some of these updates, go ahead and make those changes as well, look at what needs to be done beyond sort of the scripting possibility as well, compile it, test it, maybe even run the unit tests and see what's going on, add to the unit tests. This is a vision conversation, right? So we can kind of do that as well, and see where that is. Well, that's kind of where we're going with Amazon Q code transformation today. So over the last year, we've been working on Amazon Q Developer Agent. We released it in preview early in the year, and then we've been working on it since then. And this is where Q code transformation basically applies the knowledge of, let me show you this right here. It basically takes the knowledge of all your Maven repositories, has access to internal tools to build, run, and test, and basically applies that LLM knowledge to resolve issues and do the rinse and repeat for you automatically. And today I'm really excited. I know Ilya is going to share a little bit more of how we've been working on improving that rinse and repeat cycle for you to get you closer. Now here's the fun part I'm going to ask this whole audience. Do you think this is a nice magic button that out pops a complete app? I'll say no, right? Yeah, I got a few no's. Awesome. So, right? The whole plan is it's allowing you to accelerate this, right? So rather than starting at step 0, you're hopefully starting at step, say, 40 or step 50%, right? And it's giving you that acceleration as you go through, so then you can actually ease up and go and do the rest in an automated fashion without actually having to maintain any of the tools in terms of, scripting or any of that. Cool. Well, enough of talk. Let's take a quick look at how this works in the IDE today, and I'll hand it over to Amber. Oh, I should have. All right. Okay. So I've loaded a sample project. So currently, Q code transformation is an IDE experience at the moment in time from a developer experience, because you still have to probably make some changes as you go through. You'll simply open a Java project as you go through, a Java 8 project. You have Q chat available on the side. You'll go ahead and type in /transform, select that tool, hit enter, and it's, oh, let me see if I can do that in, there we go. Is that better? Awesome. I can't do it in IntelliJ. Somebody let me know how to do it. I'm going to switch over for a second. Okay. But it basically goes and picks the project. You go ahead and choose your source code version and click confirm. And then choose, you can run your unit tests, or you can go ahead and skip them if you like. Confirm that, and away you go. It's going to go ahead and basically go ahead and package. I'll enter my JDK path, of course. But it will go ahead and basically grab the JDK, compile it, and upload it. Rather than having you guys wait for this, I have gone ahead and recorded this because it takes a little bit to run through. And let me walk you through these details. Okay. So it goes and starts the build process. You can go ahead, you can see it's going ahead and build it. I fast forwarded it a little bit just to save you guys time. Once it's done, it will go ahead and scan the project, package all the dependencies up, and then upload this to the service to go ahead and start compiling it. So the first thing it's going to do is compile it in Java 8, make sure it works well within our sandbox. Once it's done that, it will go ahead and start applying some of the changes. The initial thing what it's going to do is, when it's done that, is provide you a transformation plan, tell you what changes it will potentially make. And then once it's done that, it will actually start applying some of those changes. Now the fun part is, it gives you an initial transformation plan. It may actually do more once it starts going through it from a GenAI perspective as well. But it goes ahead and applies those changes as it goes through, updates the dependencies, move that out of the way, and starts building Java 17. And you can see that it's actually trying to do that rinse and repeat cycle, possibly working through and seeing if it can make more changes to get it to compile successfully at some point in time. Now, once it's done, it will go ahead and provide me a transformation summary, which I can go ahead and click on and get details there. It will then tell me all the changes. By the way, it will tell me that it partially succeeded in Java 17 in this case, or in this project. So it didn't fully complete it, no magic button. It's actually telling me to log in the exceptions that have happened. In this case, it's the 509 certificate that it couldn't make the updates for in this case. But it will go ahead and give me all the changes in terms of whatever dependencies related, additional things that it added, and all the files in the end it changed as well. Right? All these files can actually be viewed. So you go ahead and just click on View Diff, and it'll give you a diff of all the details as it goes through. I can check file by file as a dev and kind of go through and walk through some of these changes. So make the changes for log4j for me. It's done the JavaX to Jakarta changes as I would like, applied some code changes as well. We can go through a few of these files to just review the details as go. So just showing you sort of the experience of how that works. I'm going to open up mat.java, go ahead and make some of those changes as well. Let's look at the POM file as well. Just gone ahead and updated my Spring Boot framework to 3.3.6. Updated my Java version, of course, other libraries in my POM XML as well. Great. But it didn't fully complete, right? So let me look at my build output. Let's take a look at it quickly, right? And it's telling me it's still got compiler 1. And now mine is a simple project, right? Yours is going to be larger, probably going to have a few more errors. But I'm just showing you that you don't have to stop there, right? I can actually go ahead, copy that error. And this is fun. I actually did this last night, by the way. So, click OK. And then I'm going to say, all right, I need to fix one of these things, right? Well, I'm going to close all my files out. Let me open up my security Java file. And I faltered. I thought it was in utils, but it was in utils. I thought it was in service, actually. And I'll open that file up. And then I'm going to go ahead to QChat on the side. This is just my chat, right? So I'm going to go back to my chat window rather than transform. And I'm going to say, I'm going to use the @workspace command, which basically allows me to put a context to my Q developer chat around the entire project. And I'm going to say, hey, can you go ahead and fix that compile error for me? And I'm going to say it's in security cert.java. I just wanted to make sure it found it. And then I'm going to just go ahead and copy paste basically what I copied from that error. And I'm going to go ahead and hit enter. And lo and behold, I was actually really happy to see that yesterday, right? That it came out with the fix or the code that I would potentially need to work through it. So while I do still need to make these manual changes, I can still start utilizing Q to accelerate some of that as we go through as well and make those changes as we go through. So in this case, it provided me those details as we go through. Awesome. All right, let me quickly show back to all right. So I hope that demo was useful. Let me hand this over to Amber, who's going to talk about how Canada Life looked at this in preview and went through it.
Thank you, Edna. Good morning, everyone. I'd like to just start by telling you a little bit about the company that I work for. For over 175 years, Canada Life has provided insurance, wealth management, and healthcare benefit products and services in Canada, the United Kingdom, Isle of Man, Germany, and in Ireland through Irish Life. At Canada Life, we're focused on improving the physical, the financial, and the mental well-being of Canadians. Whether it's handling policy claims, improving the growing and protecting our clients' retirement and investment savings, or providing workplace mental health and building stronger communities, Canada Life is committed to putting the customer in all that we do, at first, in all that we do. So our Canadian technology strategy is to support excellent customer advisor as well as employee experiences in the digital workplace. Today, I just want to talk to you about how AWS and Amazon Q helped me to support this strategy. Okay, so let's rewind to mid-2023. We onboarded all at the same time 1 million plus new customers to our digital experiences. and it didn't go as smoothly as we wanted. We had stability issues with our legacy platforms. And as depicted on the slide, we had APIs hosted on completely separate hosting layer platforms, and that was a nightmare to troubleshoot. This was the perfect opportunity for me to not waste the crisis and to go to my senior leadership and ask for approval for secure funding for an app modernization to improve our platforms onto a strategic platform. And they gave me $5 million in 2024 to do just that. So the first thing we were going to do is align to one API gateway. Then we were going to decommission all of our legacy platforms and move to a new platform in AWS Cloud. Take our databases and move them to the cloud as well. And finally, align on one messaging and eventing platform. This is the end result. This is what we would get for that. The hard benefit was clear. It was $1 million annually, but there were many soft benefits to talk about. Obviously, reducing risks of failure and outages, reducing operational costs. I hope you can imagine how difficult it was to troubleshoot through all of those platforms, which API was failing where and why and on what platform. Finally, a simplified architecture. Oh, and also enhancing customer availability, resilience, and performance, customer experience, right? Our approach was to lift and shift these APIs. We had hundreds of them, lift and shift them to the cloud. No re-architecting in any way yet. So when we started the initiative, we engaged security as we should, and they were like, no way. If you're going to move these APIs over to the cloud, you need to lift, secure, and shift them, and remove all of the pre-existing vulnerabilities that we had. Some of these APIs we haven't touched in a decade, so there was a lot. This really got me in trouble, actually, because it was the estimate increased by over 50% per API. So that resulted in $10 million of my new projected costs, and it would take me to the end of 2025. So not great. Obviously, this did, it did get me to think of, how can I mitigate this? How can I speed things up, take what would be required to upgrade all my Java 8 to Java 17, associated frameworks, libraries, dependencies. Very manual, very repetitive. It would just be a load of developers working on it. What can I do? So I went to my strategic vendors, and in came AWS as well as Amazon Q. So we decided to run a pilot to see how it would work. Amazon Q was still in preview. So we made a deal. AWS would help me and support me through my pilot, and in turn, I would provide feedback on that product. So our pilot was to determine how Amazon Q would help us cut down the time it took to upgrade and remediate the vulnerabilities. We planned to upgrade 3 different APIs on the 3 different platforms that I had shown earlier on the slide. We had a Nucleus platform, a Docker Swarm, and Rancher Kubernetes. We would have one developer start and do the API upgrade and everything manually. Then we would have that same developer run the code through the transform process, do any subsequent manual work that they'd have to do, and then document the total time for each. Our goal at the outcome of our pilot would be to achieve between 25 and 45% productivity improvement over doing it manually. Okay, so these were the results. The first API that was sitting on Docker That went well. That was a 50% improvement right off the bat. It updated from Java 8 to 17, and it also updated our Spring Boot dependency, or frameworks, I should say. I will go back just because, we talk about the manual intervention required, and if anybody else is going to start using Amazon Q, or they want to run a pilot themselves, I would say, just give yourself a little bit of time to work through application security and networking for any changes that you might have to do or approvals that you may get before starting. Okay, so the first API that we ran through, it was 50%. That was great, well within our goals. The second one, however, these are our oldest APIs that were built a long time ago. The upgrade went well, but we had Camel framework and also OSGI that were not covered by the tool. The third one was API that was hosted on Rancher. Again, it did upgrade the Java versions and the Spring Boot, but it didn't upgrade some dependencies and frameworks like JHipster and Liquibase. So, worked with AWS, who was invested in our experience and our acceleration, and they went at improving the product to accommodate more of our frameworks and dependencies that we needed for these APIs to transform successfully. So once they did that, we were able to rerun the same APIs through the Amazon Q, and we had a way better outcome with 48% increase in efficiency. This time it did upgrade the JHipster frameworks. And finally, we reran the Nucleus, the API that was sitting on Nucleus, and it added the Camel dependency in, and we got an increase of 30%, which was great. So all in all, a good pilot. Where I want to go next with Amazon Q is I want to scale the adoption. I want to, and we already do have a lineup of API modernization initiatives that will be using the product throughout 2025. Then I'd like to expand GenAI at Canada Life by leveraging some of the other features, like providing guidance on how to remediate and do the upgrades. And thirdly, I'd like to really, my end goal would be to integrate Amazon Q in my software development stacks and my development pipelines so that it could automatically remediate some of the vulnerabilities as we go. So to review, I was able to run a successful pilot using Amazon Q, yielding an average across all of those three APIs of 40% productivity savings. And not only that, but I'm improving the security posture of Canada Life's application landscape going forward. Now, $250K isn't that much in the grand scheme of things, especially with my $10 million initiative now, but it's something, the number is conservative and it's only gonna improve going forward. So it also allowed us to imagine the possibilities of where we could go from here. So I'd like to now turn it over to Elio, who I'm sure you folks want to know what's coming next and what's new with the product, how they're evolving it like they did for me during my pilot. So I'll pass it over to him to talk to you about that.
Thank you, Amber. And welcome everybody to the last part of this presentation where we're going to talk about the improvements that we're making on the Java transformation capabilities of Amazon Q. And we're going to start with quality improvements because those quality of the transformation, making Q being better at transforming the code is foundational to driving the productivity gains that Amber talked about in the Canada Life experience. To improve the quality of the transformation, we started with the debug phase. Now, before we go into detail, let's remember what Q Developer Agent for Code Transformations does. This this transformation takes your application from Java 8 or 11 to Java 17, upgrading all the dependencies and all your frameworks and removing all the deprecated API uses that are in your code base. Now, this is the flow that Adnan talked about a little bit earlier. The bulk of the transformation happens in the apply knowledge base phase. That is for a cost reason and repeatability reason. The knowledge base includes information on which library to upgrade, how to do that, how to upgrade the deprecated APIs, and it includes deterministic and generative AI-based transformations. After that happens, given the variety of the various code bases, specific first-party ways to use these things, there may still be build errors and things that those localized knowledge-based transformations are not able to fix. To solve that, we have a phase that performs many iterations of building and debugging. And that is our debug agent AI in our flow. One thing to understand about the debug agent as it was up to a few weeks ago is that it would analyze the build errors one by one. After a build was completed, it would analyze the build log, find an error, localize the error in a file in a code base, and fix the specific file. Rinse and repeat. That had many limitations. That's what we wanted to improve. So the upgraded AI that we just released in production a couple of weeks ago goes beyond one-by-one error fixes. To do this, we added a few things to this phase of our transformation. The first thing is that we gave that agent a multi-error context. So instead of taking one error at a time, we gave it all the build log, and which allows the agent to discover better solution given the wider context. We also gave the AI the ability to use multiple tools. So not only localize and fix in a single file, but browsing the code base, changing specific parameters, modifying multiple files at the same time, which allows the agent to have a much more comprehensive plan to fix a mistake and execute multi-file solutions. Another thing that has been foundational is basically adding inter-iteration memory. Instead of starting from scratch every time a build is done, the agent now remembers and has a growing context to understand what has worked before and how that can influence the solutions later. That increases consistency and reduces hallucinations because there's a lot more clarity on what worked and what didn't. Also, that enables the solutions of the previous errors to contribute to the new debugging when it's happening. Since we have memory, now we can have an agent understand if it encountered a dead end. And we gave it the ability to backtrack. So recognizing if something didn't go, I'm sure every developer in this room has reached a situation where a specific debugging branch didn't really go as you wanted, and you just had to roll back to a previous version of your code and start from scratch. And that's what we allowed Q to do during debugging. Let's look a little bit deeper on exactly how this works. So this is the debug part of the agent. So after code has been built, modifications has been done at scale by the knowledge base, the code base arrives with some build errors. That enters in a memory management agent, whose job is to identify from these results the context that will be useful to fix the bugs. Then we move to a self-critic agent. That is an agent whose job is to figure out what if what is being done is okay, and adding feedback and comments on what has happened until that point. Maybe new ideas to try, or things that are not being proposing that are not working very well. That is also the agent that is tasked to identify dead ends. If that is the case, roll back. The debugger agent takes the context from the self-critic agent, analyzes everything, and comes up with a plan to fix the mistakes, to fix the code bugs. To do that, it has access to a set of tools. They can be generic, what you imagine, file edit, browsing, file browsing, things like that, or specialized. Those are related to adding dependencies, verifying builds, and things like that. One thing that is important to note is that we're not giving Q the ability to run any commands on the code base, even in our own sandbox. That is to avoid hallucinations and to keep the plan more focused on solving the bugs. The tool execution generates some results, usually a new build errors, or maybe success, and you start again. This continues until you have a successful build or you ran out of resources. Let's look at an example. This is an example where the knowledge base just substituted old legacy uses of vector and enumeration classes with collectors. And it did that at scale with a localized context of the specific function calls that were using this thing, that they were using those non-idiomatic way to invoke these methods. So we see here, in this case, there's a collection, and in other cases, there's a counting situation, and in the final one, there's a joining. Now, what happens here is that there was, when this build log enters in the debugging agent, there's a whole slew of errors on cannot resolve symbol collectors. That is because the knowledge base did not actually add the collector's import to these files, because it's very localized, meant to be consistent at scale on many files at the same time. What the debug agent is able to do, instead of going one by one to these errors and risking hallucinating the solutions for each different files, or just wasting a whole bunch of resources solving the same bug over and over and over, each one doing a full rebuild, our new improved agent is able to recognize all the errors at the same time, plan and execute a solution across all of the files. So we see now that all the files have the added import, and this is done without having to do any build in between, saving resources, and that can now be used to solve other bugs in your code. What did this resulted into? We measured an 85% improvement in the debugging performance as opposed to the one-by-one debugger that we had before. This is on our internal benchmark of open source application, each with over 100,000 lines of code. We are also continuing to monitor the performance of this new agent in our production deployment that happened a couple weeks ago. What's to come in this area? This approach of having an agent that can plan across multiple files and has multiple tools can be extended beyond just debugging. And that's what we're planning to do right now. We're also planning to use this agent for all as the foundation for all the future development of the code transformations that we're looking at. Let's switch gears now. Of course, we're committed to improve quality. However, we also want to make sure that Q code transformation can be used more effectively and in more use cases. One of the things that we heard in the last year by our customers is that reviewing large diffs as output by Q of the transformation of a large code base is hard. One of the things that we did is that we allowed the option for running Q and asking for multiple steps transformation. So having a transformations that results in multiple diffs that can be reviewed one by one. For instance, a first one may provide you a minimal Java 17 upgrade, a second one with more enterprise library, your Jakarta Enterprise or Hibernate, and then another for web frameworks, and so on. This allows developers to focus on what's happening at each step instead of having to absorb all of the changes at the same time. A second asks that we heard over and over is, how do we use library upgrades on Java applications that are already on Java 17? Maybe you're running an older version of Spring Boot or Hibernate or JUnit, and being limited to only use Q Developer Agent for code transformation on legacy applications was actually limited the possible uses. So what we released a couple weeks back is the ability to upgrade applications that are already on Java 17 and upgrade only the libraries and framework. To do that, Q already scans more than 500,000 libraries in Maven Central and chooses the best versions considering cross-dependencies and security vulnerability to provide the most promising upgrade path. This also allows you to run the transformation agent after you fix some issues, maybe resulting that may have been resulted from a previous partial transformation. Sometimes those happen in the result of the applications having first-party dependencies that Q is not able to fix. So instead of just being stranded after the first partial success and having to do everything manual, things have been fixed manually and giving Q an additional chance to upgrade some other libraries that are still in its ability to upgrade. Let's look at a short demo of this, and for time reasons, let's just go on the video here. What we're going to see now is that we're going to look at a demo on how to do the step-by-step review and upgrading of Java of library only. We see that this application has a Spring Boot 2.7 that we want to upgrade, while is already running on Java 17. Today, Q could not handle this application. Now you can set 17 as your source Java runtime version. You can skip the unit test just for speed reasons, and you can also ask for multiple diffs as a result. This will go through the same exact process as the previous, as the demo that Anand shows, and basically now it will show you a plan of all of the things that it plans to do. So for the JDK upgrades, you see that it's going to go from Spring 2.7 to 3.3. It's going to add and remove additional things. There will be no deprecated APIs, and it's going to provide you a list of the things that it plans to change. When this thing is running, it will go through exactly the same steps. It will try to build. It will try to update the dependencies. It will try to look for things that have been deprecated in the meantime, and it will give you the ability to download your changes. And now we will see a big change. Instead of having a single diff, you see there that is the first patch of 1 of 4, and that is the upgrade to Java 17, and that also includes the Spring Boot update to 3.3. It will move all the JavaX to Jakarta across all of the files, and so on. The developer can accept each of these patches one by one. Now there's some Maven updates. This is better idiomatic use to generate hash, and there's also the difference in a POM file. What that allows you to do now is that you can keep your application up to date. When you're on Java 7, Q transformation is not only limited to modernization campaign for legacy applications. Now you can keep your application up to date even when they're already on Java 17. And Queue will keep track of the latest releases, and you can automate this process with this new feature that we recently released in preview. One of the things that we heard loud and clear from many of our customers is the requirement to automate this transformation at scale. Today, the experience is an IDE-based experience, which is great for pilots and small projects of a few applications. But when customers are running with hundreds of packages to upgrade, one of the things that they want to do is to basically automate application transformations and get and try to get to generate diffs to give to developers to verify and check. That is a much more efficient way to do things and allows you to handle lower hanging fruits sooner. There may be applications that are just successful right away, or they're very easy to do, and that can be automated at scale with the command line interface that we have now in preview. That is a very easy Python-based CLI that you can integrate in your own scripts and can also be integrated in your CI/CD pipelines to keep your applications updated. That can tell you if anything was changed, and if something was changed, a diff can be pushed to your source control system as a PR. Another request that we had, as soon as you want to go at scale, is that you may have some transformations that are specific to your code base. Think about your own custom frameworks, your own specific transformations that Queue doesn't have the knowledge base to fix. So what we have in preview as well is the ability for you to define a deterministic transformation to unblock Queue and run it at scale. This is defined as a YAML file. We're working to support multiple formats there, but the idea is to allow you to to give Queue the ability to transform your specific code. Of course, when you do that, you will still take advantage of the smart debugger that we just saw, and you do not have to code anything for it. That will be just run after your custom transformations to fix your the bugs in the resulting code base. What did we show today? The first thing that we showed was an improved AI. Again, this is very important in our commitment to improve the transformation quality of the Queue transformation agent. This is really important because, again, this is foundational to the acceleration that you will see in your own projects. Our multi-agent debugger resulted in 85% improvement on the existing debug performance of what we already had in the Queue developer agent. We also want to enable continuous maintenance. So not only a modernization project for really, really old application in Java 8 or 17, but the ability for you to modernize applications that are already on Java 17 and keep them maintained and updated. For this reason, we created library-only upgrades. We allow the ability of have step-by-step diffs that enables better reviewing experience for developers, and the ability to rerun Queue after there's been a partial success and a fix in order to take full advantage of the transformation that it can provide and the acceleration that it can provide. Finally, we had a preview of a command line interface for Java transformation. This is very important to allow you to automate upgrades and maintenance of your Java application. And it also includes the ability to run custom transformations that you provide in order to run those at scale and unblock Queue for things that are first party and specific to your code base. How can you get started? You can evaluate the transform for Java applications today to jumpstart your upgrades. Remember, as Amber was talking about, that has to be in the context of a planned maintenance and upgrade cycle. So this is not just something that is a magic wand that will make everything, your code base magically be upgraded. However, we're seeing consistently 30 to 40% productivity gains, and we expect the new improvements that we recently released to improve these percentages as well. Also, do not forget to try QDeveloper to upgrade all the phases of the software development lifecycle, not only the maintenance and modernization phases. I want to thank everybody for being here, my fellow speakers. Thanks again.